Good day, students.
Good day, ma'am.
Today's topic is probability. I think we all know that in probability we calculate the chances of an event occurring or happening. But let's recap the previous grade content. In grade 9, we only calculated the probability of compound events. Can anyone tell me what is a compound event? Anyone?
Okay, a compound event is when one or more than one event occurring.
Yes, is an event. Compound event is an event that includes two or more simple events. And who can tell me what is a simple event? Okay, a simple event is an event that can only have one outcome. We together.
Yes, ma'am.
Remember in grade 9 when we were calculating compound events, it's either you were doing a two-way table or a three-way tree diagram, depending on the question. Now let's do an example. If the question says, what is the probability of a woman giving birth to two boys after each other? So we can represent this information in a table form, a two-way table. And we can draw it like for example, if a question says, what is the probability of a woman giving birth to two boys after each other? So using this method, you can express it in this way. Right?
Okay.
The second column, it can be a boy and a girl. Are we together, Liz?
Yes.
Or
Yes,
a
ma'am.
girl and a boy, or a girl and a girl. The question said, what is the probability of a woman giving birth to two boys after each other? So, looking at this data here, the probability of having a boy, two boys after each other will be written as 1 over 4.
Oh, yes, ma'am. 1/4.
This is how you calculate the probability of a compound event in grade 9. Another way of representing the data on the table is by using a tree diagram, which is used, we can draw it like this: a boy, a girl, is it clear, guys?
Yes, ma'am.
You can represent this data on the table using a tree diagram. Now, in today's lesson, we are going to look at Venn diagrams and calculations of probability of mutually exclusive events and complementary events. Now, before we start, I want us to do a little bit of an experiment. So, the experiment that I'm going to do, I want you guys to tell me, if I toss 2 coins, what is the probability of getting a head and a tail and a head and a head, and a tail and a tail? Are we together?
Yes, ma'am.
So, if I toss 2 coins at the same time, I'm tossing them. I want you guys to give me a probability of getting a head and a head, a head and a tail and a head.
No, it's tail.
Last one, ma'am.
Oh, the
Tail
last
and a
one is
tail.
a tail and a tail. What are the chances that I'm going to get a head and a head, a head and a tail, a tail and a head and a tail and a tail? It's 1 out of 4 chances. Are we together? Yes.
Yes, ma'am. I think, ma'am, it's going to be, for example, maybe head and head. Going to be 1 over
4.
over 4. Yes.
Even here is 1 over 4.
Oh.
1 over 4. 1 over 4. Are we together, guys?
Yes.
So the chances of getting a head and a head, a head and a tail and a head, and a tail and a tail, when tossing 2 coins, is 1 over 4. Yes.
Ma'am, is it 1 over 4 because 2 coins have 4 sides?
Yes.
Oh, okay. No, that makes
Because
sense.
1
ma'am.
coin has 2 sides, another coin has 2 sides.
Yes.
So 2 plus 2 is 4.
Yeah.
Oh, and we're looking for 2 sides.
Who can tell me what do we call that? A coin has 2 sides. Another coin has 2 sides.
Yes.
So what can we head and head, tail, head, tail.
Probability, ma'am.
No. It's our sample space.
Sample, yeah.
Oh.
Meaning our sample space is 4.
Yeah.
Are we together?
Yes, ma'am.
In this lesson, we are going to look at mutually inclusive events, mutually exclusive events, and complementary events. Mutually exclusive events are events that cannot happen at the same time, and they have no elements in common. At the same time. Whereas mutually,
Ma'am, you wrote mutually there.
oh, I wanted to say mutually exclusive. Mutually exclusive. Whereas mutually inclusive events happen in the same time and have common elements. And then another type of an event is a complementary event. And complementary event, let's do an example. If we have a set of 1, 2, 3, 4, 5. If if you have a sample space of 1, 2, 3, 4, 5, and then set A is 1 and 2, the complementary event of set A will be 3, 4, and 5 altogether, meaning that the complementary event is not an event of set A altogether. And the formula for complementary events is written as 1 minus the probability of A. Okay.
So, good day, learners.
Good day, sir.
In today's lesson, we are going to look at Venn diagrams. Yes. So, what is a Venn diagram? A Venn diagram. What is it? Can anybody tell me what a Venn diagram is? Does anybody have an idea? Yes, you at the back. No? Okay. A Venn diagram. A Venn diagram is a graphical diagram is a graphical way of representing a sample space and its events. So whenever we have a sample of something, after we calculate it, the way that we represent it in the form of a graph or diagram is called a Venn diagram. Correct? So now let's do one example of a Venn diagram. Here in your textbooks, there on page 210, it says a Venn diagram. Suppose we have 9 cards. 9 cards are placed in a bag and they are numbered 1 through 9. And 1 through 9 written on them. And then a single card is selected. And then we have the following questions there. We use a different card. Number A. Number A says, what is the sample space? The sample space of the experiment. Sample space. So the statement says that we have 9 cards written 1 through 9 on them. So what do you think is our sample space?
Sample space is 1, 2, 3, 4, 5, 6, 7, 8, up to 9.
Okay, yes. So this our sample space is a representation of everything inside the sample. Everything in the sample. So because we have 9 cards with numbers on them, our sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is how we represent our sample space, and this is called a set notation. The sample space equals 1, 2, 3, 4, 5, 6, 7, and 9. And then B. B there says write down the set of event A, selecting a number less than 5. So when we look at our sample here, they want us to write event A, right? Event A is a sample of numbers that are less than 5. So when we check what numbers are less than 5, here's 5 here. The numbers less than 5 are all these numbers, right? Which is 1, 2, 3, and 4. Close brackets. Are you still with me? Yes. Let's see. Now in C, they want the opposite. In C, they want write down the numbers of events. B, we call this separate event B. Another one, selecting a number or all the numbers greater than 5. So when you look at our sample, all the numbers greater than 5 are these numbers, right? So event B, in bracket, we write 6, 7, 8, and 9, right? Still together, right?
Yes.
Yes. And then now it is time to represent our information in a Venn diagram. So now I'm going to show you how it is represented in a Venn diagram. Let me use a different card. So, first things first we have to do in a Venn diagram is draw our block. So everything that is happening in our sample will be represented inside our block. If anything else happens that is not inside the sample, will not be included in our block. Correct? Correct, yes. So now inside our block, we have to represent event A and event B. And how we do that is so. We're going to say here event A, right? And then we draw a circle. And then also event B. We draw another circle. What numbers do we have in event A? This is event A. We have 1, 2, 3, and 4, right? And then in event B, it's 6, 7, 8, and 9. But now, there's one number missing from both of our events. Which is number? Number 5, right? So, because number 5 is not in event A, nor in event B, it is not included in either of the circles. So, we just put it anywhere in the block, but not in either circle. Because it's part of the sample size, it's going to be part of the block, but it's not part of any event, so it is not included in any of the circles. Are you still with me? Alright, thank you. And then now we are going to continue on with calculating the probability happening inside the sample and inside the events. Now, let's see if this color works. Alright. This is D. When I continue here, you see the point is small, guys, but we are together. So E, it says we have to calculate the probability of event A. This is event A, right? Now we have to calculate the probability. So how we represent the probability? We say the probability P open bracket of event A close bracket. The probability of event A happening equals. So now let's go back to our event. In event A, wait, so before I continue, I want to show you a way of calculating probability. It's like a cheat code sort of. Just gonna write it here. Probability. Okay, yes. I just wanted to show you how we calculate probability. So, say the probability of an event equals the sum of that event over the sample space. Correct? So, the sum of the event or the sum of the elements in each event over the sample space, right? So now when they ask us to calculate the probability of A, we're going to use this formula, right? This formula is not in your textbooks. I just came up with it just to help you. So the probability of event A happening, right? What is the sum of our events in A?
It's
The sum of the events of A.
4.
4. Yes, 4. Over our sample size is
9.
9. F the probability of event B happening. Yeah. So now when we say the probability of B, right? Then now we go back to this formula. Is the sum of the elements of event B over the sample size. In event B, how many elements do we have? 4. It's the same as this one, right? So this is our answer. Over 9. 4 over 9. We're still together, so it's not lost lines. And then they might also ask you to calculate the probability of A or B. Right? And then here, guys, I want to show you something here. Yeah. When they say probability of one event or another event happening, this is how you represent it. Let's say maybe they say event of A or B. Right? So this is what they're asking. Right now, they might also ask you in this form. A union B, which is also the same as this symbol right here means it's the U for union, which means all. So most of the time they're going to ask you like this. But you have to know what they're saying. They're saying the probability of event A or event B occurring, right? So here, let me just help this part off. And see, the proper way how you go to in your tests and exams. Yeah. The probability of event A or event B, right? So now, what do we do? What do we do from here?
Addition of probability of
And addition, right? Okay, correct. So we're going to take these answers. We're only calculating the probability of A, right? We've got 4 over 9. And we're also calculating the probability of B. We're going to get there. Also 4 over 9. So now, basic maths, 4 over 9 plus 4 over 9 equals 8 over 9. 8 over 9. 8 over 9. And then we also do this, put in our calculator, say 8 over 9 equals, because SD, it's 0.88. But now we have to represent this in percentage. Thank you. So we times by 100. So therefore, it is, we have 88,888. So basically it's 89% round off, it's 89%. So now when we try to understand this question, they're asking us the probability of A or the probability of B. So when you throw the dice, then the chances of you landing at 1, 2, 3, 4, or 6, 7, 8, 9, the chances of that happening is 89% or 88.888%. Right? Yeah. Still simple, guys. Still with me, right?
Yes. Okay, we will do exercise 1 on page 200. The first question is 10 balls numbered 1 to 10 are placed in a bag and one is chosen at random, right? So 1A, we're gonna use the letter O to represent the event of getting an odd number and represent it in a set notation. So O, this is the set notation. So what are the odd numbers? We have 1 to 10. What are odd numbers?
1, 3, 5, 7, 9.
These are our odd numbers. So B, we use letter E to represent what? Even numbers. What are the even numbers?
2, 4, 6, 8, and 10.
Right?
Yes, ma'am.
So, see, we're gonna draw a Venn diagram. As it has been explained before, what is Venn diagram and what can be expected from Venn diagram. So, we have this block, and we're gonna have event O and event E. So what is it that we're gonna find in event O? Is
Odd numbers.
1, 3, 5, 7, and 9, which are odd numbers. And the even numbers, we're gonna find it in
Event E.
event E, which are
2, 6, 8.
10.
Yes, ma'am.
Right? Then after that, we're gonna determine the probability of getting even numbers. Name. So what is the probability of getting even number? Probability of getting even number.
Even numbers. 5 over 5
We
elements
have
in
how
even.
many? 5.
Yes,
5
ma'am.
elements. Over how many?
Over a sample of
Sample of
10.
10. And then E, we're going to have to find the probability of getting what? Odd number. Okay, what is it that we get in event A? Oh,
We do have 5.
we have 5
elements.
over 10.
10.
Samples.
Yes.
Then number F, we are asked if the events O and E are mutually exclusive. If event O and E mutually exclusive,
Please.
event O and E, are they mutually exclusive?
Yes, ma'am.
Yes, they are also mutual. They are mutually exclusive because of what? They have nothing in common, no elements.
No common elements.
Yeah, no
Yes.
common elements.
Yes, ma'am.
So yes, they are mutually exclusive. And for G, events O and E complementary events. Yes. Why?
Because, ma'am, let's see. When we
Because
minus.
for O, the one that the probability of not getting O is equal to what? 1 minus what?
The probability of O.
Of O. Same applies with E.
Event E.
Probability of not getting E is 1 minus E. Probability of E. Okay, now we're gonna do the example of mutually inclusive, because of the one that we did previously was mutually exclusive. So now it's mutually inclusive. So here we're gonna determine the probability of event A and probability of event Q. And then after that, we're going to determine the probability of event A and Q, of R and Q, sorry. So the probability of event R is equal to what?
1, 2, 3, 4, 5, 6.
It's 1, 2, 3, 4,
5, yes.
Our sample space consists of how many?
10 elements.
10 elements. And the probability of Q consists of how many elements?
6, 2, 4, 6.
It's 6, right?
Yes, ma'am.
6 out of 10. Okay, now we're going to calculate the probability of R and Q. Okay, now I'm going to show you how to, if ever you are asked to determine the probability of R or Q in this form of like when they are mutually inclusive. So our probability of R or Q is equals to probability of R, everything that you get in the event of R, plus everything that you get in the probability in the event of Q, minus the events that are mutual, which are common, that we find in the event of R and in the event of Q.
Yes.
So you're gonna minus the probability of R, and the sign, you must be aware of the sign, it changes. Q. So what is the probability of R? It's 5 over 10 plus the probability of
Q.
Is 6 over 10 minus the elements that are common, which are, it's 2
over 10.
over 10. So 5 over 10 plus 6 over 10 is equal to 11. 10 minus 2, 10. Which is equal to what? 9 over 10. So that's how you calculate it. So now you can see the difference between mutually inclusive, mutually exclusive. You understand that?
Yes.
Yes, ma'am.
Yes, that's it for today. So you will have to work on the homework that you're gonna find in page 210 in your textbooks.